this is kind of information. Okay, so in our life, we live with a bunch of information. So we try to manage such information with the help of computer. Specifically, we are going to use the database system. For the database system software, we are going to use relational database management. RDBMS, so for example, the MySQL database. So using this one, we'd like to manage such information. That's our goal throughout this method. This is the designing process. It cannot be done at one time. I know that some of the students already used such a relational database like a SQL Server for your programming assignment. At the time, you just skip this process because your database was just simple, like the couple or the several table. Unfortunately, in your real project after graduation, your database will not be such a simple. So you need to understand such a process. So probably you will be part of such a process. However, you better understand the entire process. So instead of creating directly such a table or whatever, the database object, we are going to start the database design, the step by step. The first step is this is just the information. It's not organized. Okay. Think about your process to clean up your room. When you clean up your room, you are not going to collect and manage or organize at once. So first you design. I'm going to put the my books over there on the bookshelf. I'm going to put my clothes on the closet. And I'm going to put the sleeping stuff over here, desktop over here, like that. Such the conceptually you design such a thing. At that time, you want to collect the items that are similar or the same thing. So you try to put all the database textbook on the first bookshelf, and the second bookshelf is the operating system, like that. So that is the first step. It's a conceptual. We are not going to use this system yet. We are not going to put your stuff on the bookshelf or close it yet. Just conceptual design. So that is entity, relationship, the modeling. So this is called the ER diagram. So ER modeling, entity relationship model. If you consider the super and subclass relationship like this one, this is called the ER diagram, ER model, extended ER modeling, or enhanced ER modeling. This is called the conceptual modeling, or this is sometimes called the logical database model, because it's just a conceptual logical model. So when you search job, sometimes you may see the job description requirement, 3 years of the conceptual level design, like that. But the most important requirement of such a conceptual level design is domain knowledge and experience. If you do not understand the finance, you cannot build a finance database model. If you do not know the biological, the concept and the terminology, you cannot design the biological database, and so on. Okay, so that is the first step. However, this is not good enough to create the table database object using the database system. The next step is we are going to still use the ER model, but that's close to the system. So that is called the database model. Sometimes this one is called the data model. We focus on the data, but this one focus on the database model. When we are saying the model, as we discussed, model is it's a rule, bunch of rules. It's a constraint. It's not free. Okay, there's a certain very strict rule. Okay, so collection of such a rule is called a model. Or sometimes, so think about your object-oriented model. Object-oriented model, you design the OP based on what? Data and the method. So first you find the variable, name, ID, address of person. And you can search as a method. You can delete as a method. What you can do is only this data and method. That's the restriction. design a model of person class, like that. So this is the model rule for database. This is a rule for only focusing on data. It's like, on the other hand, this is a conceptual level. It's more like the physical database model. Okay? So, in this database model, we are going to use the same thing. For the conceptual model, there are a lot of different models. But nowadays, the ER model is the most popular one. The reason is that, as you have seen, it's simple. You can understand easily. We spend a week, but everybody understands concept of that, and very straightforward, and also it's flexible to be used for many other data and database software model. It's not only for the relational database, it can be used for even object-oriented model, it can be used for the many other model. And also, database model, it's more like the database to design, to get close to the database system. So at the time, we are going to define relation. So today, we are going to see what is the relation, and based on that, what is a relational database model. Okay, so it's very similar, like this one, but slightly different. But this one is getting close to this. However, that doesn't mean that this database model is the same as your database. So we need to create the database based on this kind of blueprint. Okay, frame, blueprint of your database. At the time, we can use, as we have seen beginning of the semester, the SQL language. We are going to use the language, database language, data definition language, data manipulation language. So today we are going to learn what is this one, relational database model. It's a database model close to this, but it's very similar as the data model. But the difference is data model is focusing on data itself. It doesn't relate to any database system or software, so on. On the other hand, the database model, more like the database structure. Eventually, this one will be used for creating database. Okay? For example, if you are using the MySQL or SQL Server, Oracle, DB2, those are the software which are based on the relational database model. So this is the RDBMS is the software, this is the model. Okay? In other words, so if you are very familiar with MySQL, what about Oracle, SQL Server? They are based on the same database model. Okay? Relational database model. It's a standardized, it's a common. So it's not very difficult, it's almost the same. It doesn't matter. So some of the students complain, I'd like to use the Oracle for the database project. And because I have used before, or I want to know how to use the SQL Server, it's not different. They are based on the same database model. Roughly 70–80% of the functionality of any relational database, they are exactly the same. Okay? However, interface is slightly different. So for example, Oracle uses the command line interface SQL Server, MySQL uses MySQL, DB2 uses the DB2, like that. Okay? Very similar. Even syntax-wise, it's the same. So this, and plus another different thing is the database procedural language. It's the procedural language. So we will see what is a procedural language later. This procedural language is not standardized. Okay? So the other SQL part is standardized, so you can use any of this. It's compatible, but the procedural language is not compatible. So we will see such a difference later. So today we are going to see what is the relational database model. Okay, to start such a relational database model, so we'd like to quickly go over the history of database. Okay, So we try to quickly, because I skipped I think the chapter 1, the second half of the chapter 1 to save the time. At the time, what I skipped was is a history of a database and the different types of database model. Okay. So if you are asked what is the first computer system, what will be your answer? What is the first computer in our history? Calculator is the first one. It's starting from the long time ago. Somebody says 5,000 years ago. It's almost a similar time as what the human civilization was happened. Because at the time it is true the people would like to form a group of society, but somebody should govern, like the security and so on. So we have government, like the king. So they need to collect the money, like the tax, from their people, whether one is a slave or whatever. Anyway, they need money. So, but it's not simple to collect just the money. Somebody complains, so they need such a calculator. So calculator is a long time ago. So like from Babylonian, so they invented like the old style calculator is the abacus. Abacus uses some small stone. So you have seen such a thing, and you heard about the Leibniz and something calculator, something Pascal calculator, and so on. But those are calculator. It calculates the number or the value, but without electricity. So when we are saying nowadays computer, most of computer stuff is an electronic device. So modern calculator utilize such an electric power. Have you ever thought about why we are using electricity for computer or such a calculator? Now we are using a lot of such electricity, like the camcorder, the cell phone, any device. So we are using electricity. Sometimes the DC power, like the battery or AC power, but we are using electricity. Why?
Computer can understand only 0 and 1.
Yes, that's the key part. Then the why electricity?
Signal to sensor.
It's a signal. So we can make this a very good point. Very good answer. We can easily make the zero using the electric current. If using switch, if you block the current of the electricity, it's a zero. Zero is not nothing. It's actually like the current. So less. But if you on, this is a high current. Current is the flow. So we can easily represent such a difference. So we are going to regard this is 0, this is 1. So then this is a binary. So you apply the code, like the ASCII code or Unicode. We can represent a lot of the alphanumeric data and eventually image and video and so on. So computer actually very close to this. So because of that, so we are using electricity to operate the computer. So then we start something electricity ENIAC, ENIAC, 1940, 1950, we had such a computer system. So that is the kind of first generation of the computer. So first time when we have, so what is the simple architecture of the computer we talk about? We have CPU. The CPU is the processor. Process information, not just information, it's a instruction. So if the manufacturer like Intel, AMD, and who else? IBM no longer produce the CPU processor. So such a manufacturer design first how many instructions, add, subtract, move, and so on. Such a number of instructions is embedded, coded inside. Then if you are taking the electric digital circuit and so on, you learn how to design the add using the electricity. right? And so on. So each CPU has such a ALU, arithmetic logical unit. Then based on that, we can have the instruction, command, simply. So machine level command. Then this command, this instruction are not in CPU because CPU has very small and less storage, like the register. So we need to bring such a register, and not register, the data instruction from memory. So then the CPU and memory are connected through the bus. So this is the von Neumann, the computer architecture. The main part of the von Neumann computer architecture is this part, the memory. Okay. Then this memory is also not big enough, so we have file system. To operate this computer, we have operating system like Windows, Android, and so on. So this is our computer. So first generation of such a computer, huge box, any box, they use the transistor rather than the VLSI like that, but their architecture are still the same architecture. Then when they start, they have also data. Some of the computer at the time is embedded the system. It's not programmable. This computer is only for the calculator purpose. So you cannot change it, the objective or the process. Okay? But eventually this, which means you cannot change it, the code. Code is inside, is fixed. However, eventually, with people need more flexible computer, it's a programmable computer, like using punch card. So we have such a punch card. So this we can represent the binary using the punch card, whole or nothing, or nothing, and then we can make the program. This one read this, the coded the information, then the operate the process, such a thing. Then still it has the data. So computer has the data. It's just the first time the number, but eventually more complicated data. So first time, after we have the first generation of the computer, data is inside. Everything is inside. So even we didn't have network. Network was not used at the time. 1960, 1970, almost 1970. At the time, they people thought about to connect the different data. But until that time, computer has everything inside. CPU, memory, and disk, and the data, so everything, even the monitor and the mouse. At the time, this monitor mouse, we didn't have such a universal bus, the USB. Instead, we have used console and directly connect, like a PS2 interface, like that. It's a dummy terminal. Yeah, it's not like our screen. It's just a dummy terminal. It's not computer. It's a CRT monitor. And the mouse and so on. Mouse is later, but everything is connected. It's a one box. So this is called centralized the computer system. Centralized computer system. Centralized computer system having everything, including database. So database was used a long time before. So even at the time, such a database has the different model. So one way easily still being used is you can organize the data. Actually, you are very familiar with this approach. Like in my tradition, so I'm from Korea. Korea has each family maintain and manage long history, family history. It's actually our family. I heard that it's a 30 the old generation. So my several ancestor was a part of royal family. I didn't get any benefit. But after that, it is I think the 27th, the ancestor, he started the new family tree because his brother became the king. So which means that usually such a royal family, they don't allow such a thing is the kind of royalty. So he started the new family group. So then I heard there is the almost 100 books like that for the family tree. So it's very complicated to read, find my name from the book, but very basic idea is what? The parent and the second generation, their children, like that. This is called family tree. It's a tree structure. In other words, tree is called what? We mentioned there's such a name before during the EER modeling. What is that? This one is called hierarchical model. So we can use such a hierarchical model, tree structure, to manage the data. For example, one of the popular example of such a hierarchical model in our computer application is a bank. The bank has, this is a bank, has a number of branch 1, branch 2, branch 3, branch 4. It's a Bridgeport branch. Bridgeport branch has what? Account, saving account, checking account, credit account, loan account, and customer information. Same thing for the Fairfield branch. This one is customer and checking, saving, credit, and so on. If you need, you can have more of the saving account 1, saving account 2, saving account 3, like that. So you can organize, manage the data using hierarchy or tree. Then how can we use such a data? So first, I'd like to search my bank account, the saving account balance. So you can start from here. I'm in Bridgeport branch. Then saving account and account number 1. Then the balance will be returned. It's a very fast. What is the complexity of the when you search data using binary tree? Do you remember that? Binary tree is how many children? Only 2. When you search data, what is the complexity in terms of big O notation? You learn in your data structure class. Tanya?
For binary tree, I'm not really sure.
You can guess even.
I'll assume
N number of node.
so log n
Log n based on
2.
2. You can guess even. So that means 2 and this one is value 11. Okay? You can get the benefit of the searching the tree based on the 11. Okay? So otherwise, if you have the linear n, it will be n over 2. So huge difference. So you can, without changing anything, just organize different way. You can save a huge benefit. Like this one and this one. That is the benefit. The beauty of the tree structure. We can get such a benefit of using hierarchy. So this one still being used. Also another benefit is it's very simple. You have the function like the next. It's called the really get next. Next level, just value my account Bridgeport and saving account. Bridgeport and saving account, like that. Then return the data and secure. So this one is the hierarchical model. You can, if you organize your database based on this one, it's called the hierarchical database model. Still used. Problem. If you have a account here, Bridgeport and Fairfield and Dallas, how can you get the average balance? And up and down, backtracking. You need to do a lot of backtracking. You cannot get the full benefit of the log n. Not to you have the multiple children, roughly log n. You cannot get the log n benefit. Okay. Also, nowadays it's easy to get the total balance from the one bank, even several banks, right? This one is really slow. So nowadays, this one is not the good database data model to accept. It's not flexible. There's no flexibility of the hierarchical database. So this one, even though it's used nowadays, not very popular. Another approach it's called the network database model. Network database model is related information is connected like the network. So students take the course at the School of Engineering like that. They are connected based on the flow of the data. It's from the network. So this is called the network database model. Okay. So, but I never seen the practical example of the network. I learned from only the textbook. So this is another one. There are more, like the object-oriented database model you can use. What is a key part of the object-oriented database model or object-oriented model? Any model, the main purpose of any type, any kind of model is searching data. Okay? It takes long time. It's a slow searching. You don't use. You cannot use any model. Okay? Object-oriented database. Object-oriented model. How can you search the data? Using object ID. Object ID will be represented by the reference, so address. So it has the object ID. So based on that, you can define the object using class so that you can access the data. So if you design the data using the object-oriented model, yes, that is called the object-oriented database model. So hierarchical database model, network database model, object-oriented database model. Then we didn't talk about the relational database model yet. Somebody proposed object relational database model. It's kind of in between, like that. There are many, but in this one, use hierarchical database model, or it's called the file system based, file-based database. It's called the ISAM file. File itself is indexed. Indexed sequential access the method. The file itself has the data structure. It's an index inside. So it's called the ISAM file. So IBM still uses such an ISAM file. So file itself is the index like that. So this is a centralized system. Long time we use such a centralized system. Put everything in a computer. Then the database is a part of this. It's a centralized database. So we have been using such a centralized database until when? 1980. Something happened, the 1980. Do you remember what happened 1980? You born at the time? Probably not. So 1980, so Steve Jobs, he released the Apple computer, so 8-bit, 16-bit computer, like this shape. It was like the 2,000, 3,000 bucks at that time. It was expensive computer. It's a personal computer. So 1980 is kind of an era, decade, when the personal computer started in the market. Even though it's expensive, it's a personal computer. Personal computer keep everything. So then it's getting more powerful. CPU is faster, memory is bigger, hard disk drive is cheaper and cheaper. So even individual, for each family can purchase the computer. Until that time, it is only for company because it's really expensive. If you search the Google, the price of the 10 megabyte hard disk drive at the time, 1970, 80, is $5,000, $6,000, something like that. But it's getting cheaper. So we have a PC, personal computer. Another thing is the happen is internet, network. It was started. First time is for military purpose. So we had something the A and B set up the two node and connected to the wire. Then apply the protocol. Protocol is kind of agreement between you and me because they cannot send the data as we understand. Instead, it's coded. Then there's a specific rule to send. It's a base. Eventually, it will be set OSI 7 layer. Okay, we have the conceptual at a different layer. Then the TCP/IP is the third, fourth layer, TCP layer, and IP layer, and application layer. We are using HTTP and so on like that. So then that means the network is invented and is getting powerful. So based on with the help of PC, personal computing power, and network, so we address the problem of this. The main problem of this one is getting bigger and bigger, right? So database is here, and the file is here, everything is here. We need more powerful computer. How can you make it more powerful? How? You need to replace, buy new one, bigger one. Every time, replace. It's a cost. It's really high cost and also dangerous. It's risky to migrate every time, okay, and painful. So this is not acceptable. Instead, people would like to use the benefit of the personal computing power and network, which means we minimize. So I think every year, the beginning of the year, many of the people, they make the new resolution like the diet or the slim like that. Not me, but I need to think about. So we can slim this one. We keep the only important part of the computer in this. Then this part is the takeout. What kind of interface? Graphical user interface. Or the computation part. It's a PC. Because the power of a personal computer is higher and higher. So they are good enough to take in charge of some part of computer system, centralized computer system. Then, problem is, this is not part of the main computer. We need to connect using what? Network. So with the benefit of the network and the personal computer, we can separate. At that time, this is called what? Server. And this one is called client. So this is called client server environment. This is called centralized. This one is called client server architecture. Client server computing environment. Client server. Somebody said this is one tier. This is another tier. So this is called two-tier computing architecture. So database use the same architecture. This is a database server. This one is called database client. So from client, you connect the database using what? Network. Mostly you are using TCP/IP network and connect the database. Then you can actually take apart some part of the burden of the server to the client. So, for example, you spend a lot of time, fancy, nice interface. Then where your program is running? Client, your PC, not server side. Then the server doesn't have to worry about such a computing resource. Instead, client, your PC is good enough to run. So this is a client server. What to tier? If you are thinking your database project, I'd like to build a client Java application and connect the database, which is two-tier environment because it's connected. Then this is a cloud server. Then it's a two-tier. Okay. So we can address a lot of problem of this one. Instead of replacing everything, we can just upgrade database. Okay. And if we need more user, just connect like this. However, still this one has the problem of what? One time when I was database administrator, we have 3,000 employees. So 3,000 employees, in the morning when they get into their office, they connect the database because they need to get the customer information and the report, a daily report like that. And then whenever each employee, each computer is connected, what happened? So how many of you took the network class? Network? Distributed network class? Network class? Yes. Wherever. So network. So network. So in your class, did you have the kind of programming assignment for the implementing circuit program?
I just had the lab.
Yeah, in the lab. It's a circuit program. Circuit program is client server. Then using TCP/IP, you can connect, you can send and receive the message. And what happened when you create the circuit? What happened? From your client program and connect to the server, what happened? It used first create the memory. It's a process. So like the 10 megabyte. And this memory will be accessed by the CPU. CPU, if you request something and I need a file, then this one, memory, will be accessed by the CPU. CPU know your request and return the specific file like that. Which means, whenever your client is connected, computing resource of the database or server side will be used. At the time, when I checked the memory only at the time, so each client need 15 megabytes of the memory. But if you have 1,000 users, so 15 gigabytes. If you have 45 gigabytes of memory will be used only for what? Connection. Problem is, all the employees, even though they check the check-in and check the yesterday, the daily report, they will not log out. Why? They want to pretend they are working. They never ever log out until they get out of office. So this connection is alive. So 45 gigabytes of memory, we cannot imagine at that time. So 1990, we cannot imagine. There's no, even hard disk drive is 32 gigabytes is the biggest one. So system is always down, no connection like that. So this address some part of this problem, but cannot permanently. So we thought about only few of them among the 3,000. When we check the live the transaction, okay, active transaction is only 10. That makes sense. When you check your task manager or the MacBook or whatever, only one or two processes are active. The other is waiting or idle. So from that point of view, instead of connect everything, so think about when you search your car or the house, are you going to contact the bank directly? Like the Bank of America, what is the interest rate and can you borrow the money? And go to the Chase Bank and here and there. Instead, you can contact broker. Then you need to give some commission. But broker will search bunch of them, then cheapest one. You will get the benefit of that. So similarly, instead of connect the server directly, we have the server, and we have 3,000 clients. Then there is a broker, like that, in the middle. Then this one, dedicated database connection. Always live, but it's not assigned to any of this. Instead, if client request, check whether this is available or not. So we have the, let's say, 20 live bridge between server and this one, broker. Then this client will ask, check the live one. If this one is live, assign. If transaction is done, then disconnect and assign the next like that. Okay? At that time, this is called middleware. Middleware. Server, client, and middle. Sometimes it's called 1, 2, 3 tier architecture. So this one is called the 3-tier architecture. This one is transaction management. This is sometimes called the TP monitor or middleware. Nowadays, you are using every day. You are using this one. What? Web server. Web application server. It's not just a web server. It's called a web application server. This is a web server, and whenever user requests, this web server connect the database and return the data. So nowadays, most of the web server has such an application server. So like the IIS, Apache server, Django server, such a server is in charge of transaction management. So this is called the 3-tier. So if you are thinking in your project, like I'm thinking my project based on the Django is a web server, web application. So client is what? Browser. You don't have to spend a lot of time, but you need to design the output like the HTML, CSS, and so on. But it's not like the fully implementation of your GUI, graphical user interface. Then you set up the application server and connect the database. This is a 3-tier architecture. Okay. Nowadays, more. So we have the centralized database and the server and client and server, 2-tier, the database system, and the 3-tier. Because of that, this is called what? Back end. It's the back side. And this one is called front end. So user interface part. 3-tier architecture. There are additional layer, 4-tier, multi-tier, but security will be added. But it's based on the 3-tier, basically. But nowadays we have peer-to-peer. There's a server client, but P2P does not have server and client. It's each peer can be server and client. Server like the blockchain and anyone who are using torrent to download the movie illegally. So such a torrent is a P2P. Okay? You are not server, you are not provider. Because of that, it's not illegal. So because you do not share the entire contents, only piece of them. However, after you download, if you are using such a contents for public, it will be illegal. It's copyright violation. But if you are using for your personal purpose, like watching the movie at home, so it's not a problem. Okay? It's not share the entire content. However, nowadays we don't have such the application like the lab. What's the name of that? Who provide the information, location of that the file, torrent file itself. If you manage such a thing, it may be some part illegal, some pirate. So what's the name of site? Pirate.com? Yeah, such a thing. Such a who provide. It's just many of them illegal. But using as a consumer, using such a P2P is not a problem unless you use it for public or the other purpose. Personal purpose is. But P2P, There's a P2P based database system, but we do not cover, and also it's not very popular. Nowadays, the blockchain can be used for, it's not only for the Bitcoin, it can be used for the database also. More secure, but still the several issues. So this is the overall history and architecture of the computer system. So you can imagine what kind of architecture you are going to use for your the method and the project. Then what we're gonna do in this class is we drive to the design. So beyond the network database model, what else? The hierarchical database model, they are limited, as we have seen before. And the object-oriented database model is too flexible. So 1970 is before this one, even people encounter such a problem. Size is getting bigger, so we definitely need a different organization of such the data. So Dr. E.F. Cole, so who is the researcher in IBM T.J. Watson Center. So he and his colleague proposed idea of how to manage very large data. Even though he said that it's a very large database, maybe size is several megabytes, but it was huge, 1970. So to manage the very large data, think about the nowadays the big data. When we are saying the big data is like the petabyte and several petabyte exabyte. So even hard to imagine how many zero, how many digits of the petabyte, whatever. But it depends on the computing power. Considering computing power, if your if your system cannot handle such a data size, it will be big data. It's the same problem at the time, 1970, 1969. So Dr. E.F. Cole and his colleague proposed new idea how to manage the very large banking data. So idea is simple. So any question regarding to this one? This is not directly related to the exam question, but it's worthwhile. Okay, if you have the overview of the history and the architecture of such a the system and computer, it's not only for the database, overall computing, the power and computing organization. So you may imagine people how they address the problem of the computing power, how to address the efficiency, and so on. So right now, at the time, our problem is the size of data. So our data size is so big to manage. Okay, probably at the time they assign the variable integer in their program language, and sometimes the character, and then for the string, they use the array. But when we have very large data, so we need to define each and everything. It's really slow and we cannot. It's not efficient way. So the EF code thought about, is there any other way to manage such a very large data? So it's not the really new idea. We think about the math. In math, so one of the biggest problem of the math long time ago was, how can I deal with the number? Number start from natural number. Natural number is 1, 2, 3, 4, which the human being can count. How many number can you count? 1,000? 10,000? I don't think that you count over 1,000 number, even though you couldn't sleep long time ago. Your mom probably said, why don't you count until the 10,000? But people cannot count such a number. But unfortunately, number is infinite. Then, for example, how do you guarantee? In the natural number, A and B belongs to natural number is equal to B plus A. Associative property. Do you believe it's true? Yes, we know it's true. How can you believe that this is true? Why not? Did you test everything? Nobody tests each and every case. We cannot do that. The proof. The each and every. So sometimes we can define the axiom. Not all of them are axiom we need. Still, the number itself is infinite. Doesn't make sense. Even though we never been there, but we design and plan, so it doesn't make sense. So it's the biggest problem, such infinity. So it's kind of the math history is kind of the struggling from the such an infinity number, the characteristic. So how can people, mathematicians, address such an infinity problem? They use set. Okay. So what is n? Instead of it's a natural number, how many number? We don't know. But they define n is 1, 2, 3, 4. Such a number. Okay? This is a right there. Or sometimes n is whole number. Like this. Using this set. We can even define. It's a group of elements, group of data. So we can, instead of considering each and every number, we decide this is the whole number that can be countable. What about the irrational number? What about the integer? Integer is the opposite side, include minus the negative, the infinity to the infinity, plus 0. Then what about the irrational number? Irrational number is a combination of natural number a over b, like that. B cannot be 0, like that. And the rational number. So we define, but all of them are in their set. Okay. So idea of the such a set is a grouping. Huge difference. Instead of considering each and every element, we consider as a group. Then inside the group, this A and B is inside the natural number group, natural number set. Then we can prove and sometimes assume as an axiom and like that. So this is a set. He tried to borrow the idea of the set to manage very large data. For example, Lee 1 and the CS. This is an entity we define. And James 2 ID and E. And Potter 3 and C E. Entity, 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 right? Then this is the entity, type, name, ID, and major. We consider each entity as an element in a set. So element 1, element 2. So James 2 E. Potter 3 C E. So how many elements? 1, 2, 3. Then make the set. Okay? So, however, each element should have what? Name, ID, major. Name, ID, major. It's a standardized. Okay? Very similar as the concept of ER model, but don't forget about ER. Okay? Later we will see. So, when we manage the data, name, ID, major. Name, ID, major. Name, ID, major. So Lee, we have James, we have Potter, but don't care. Just each person, each student as a name, ID, major. Name, ID, major. So this is a student set. But we are going to define student. It's called a relation. Because this is a set, but if we are using the same terminology, same name, confused. So instead of using set, the Dr. EF code proposed, why don't we use name of relation? This one will be eventually the table, exactly same thing. But it's when he proposed, it's called a relation. So this student table, student relation has name, ID, major. like this. Okay. Then, whenever we access the data, please give me what is the name, what is the ID, what is the major. Then we can search the data. When you stack up in the cabinet or the storage memory, so we are going to store in this format. No matter how many data we have, just a simple process. So this is the fundamental of relational database model. So when we are talking about, when we are saying that I have experience on the relational database or relational model or RDB, R means what? Not relationship. It's called relation. Actually, relation is when Dr. Yef called naming. He tried to think about the kind of alternative way of set. That is relation. But it is true. When you find the form of relation set, element inside the same relation should be related. Right? Relate means say name ID major, name ID major, name ID major. We don't want professor. Right? They are related. But when he name it, it's called a relation. So this is called relational database, the model. Idea is really simple. Relational model, consider data as a group. Okay, so always see what is the relation, and the more the concept, constraint, rule to learn what is a relational model. Okay. Any questions so far? So, this is one of the most popular paper in computer science. So he was awarded as a Turing. The award. Everybody knows who is the Alan Turing. Alan Turing is the father of computer science because he used the computer design and invented computer first time to solve the problem of what? During the World War II, decode the Germans' message like that. So everybody used his genius, genius in the mathematics, but he tried to use computer to solve such a problem. So to respect his work, we call Alan Turing is father of the computer science. Also, we award the researcher who most cited, most referenced paper. Okay, so his paper, so relational model of data for large shared data bank. Large, actually, it's not really large from the nowadays, but it was large. So Dr. Yef called. So then his colleague proposed the relational model. When 69, then the officially published the 70. What happened during the 1969? Neil Armstrong landed on the moon, 1969, July. I think the 2nd and 21st, like that. Last year was the 50 years anniversary. So then we celebrate. So Dr. Yef called the proposed relational model, 69. And Neil Armstrong landed on the moon, the 69. Then third one, most important, Professor Lee was born. 69. Okay. So, what is the definition of the relational model? It's a set of rules. It's a group of data. So we consider group. Then problem will be what? How the group is organized using attributes. So attributes. So our goal is to find such attribute is called a column. So if you are not sure what is the relation, think about the Excel file. It's a tablet style, then it has a table view, right? And this is called column. This is called what? Rows. In database, it's called a tuple. So if you read the technical paper, they do not use name of a row or name of column. Instead, they are using tuple or attribute. More academic way. It's exactly the same meaning, but more it's knowledgeable and intelligence like that, but it's the same meaning. So this is our goal to design later. So this is called a relation. So we have a relation name and their attribute. So our goal is to find. But somebody may be curious. So Professor Lee, as you have called is define the relation student has group of attribute name, social security number, like this. Yes, I understand. What about this? If we do not have this, we do not have the attribute. But if we have the 1, 2, 3, 4, 5 tuple, 5 sample data, all of them have the same domain value. It's also what? The relation. So relation is not only just a group of the attribute column, is that in addition, so we have, if we have the number of group of data, each data has the same format, common, okay? Identical, then we say this is a relation. So there are two ways to define the relation table. One is group of data. So we did in the ER modeling, entity, 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 entity. Then we realize all entity has name, ID, major. That's one way, group of data. Also, from description, like the handout, we found name, ID, the major. Then define the student. So that is also definition of the relation. So two ways, either way is fine. So if you do not have the data, you can find from description. If you have data, you can define the relation from the data. Then the name, social security number, and so on. This is the relation that we are going to design. Then from now on, this is a modeling. So modeling has a lot of rule, constraint, concept. So first is the key. Okay? What is a key? Key.
Recognizable action.
When you get into the room, okay? When you open the room, your key exactly fit to the key box only, right? You don't want to share your key box to the other, right? Each key fit to the only one key box. So then you can access, you can define. Same thing, when you search the data, our goal in computer science, mostly our goal is to find the data. That's the ultimate goal. In other words, if your system, if your algorithm, if your database is slow to search data, forget about it, throw away. Okay, it's not good. So when we search the data, we can use the name, we can use social security number, phone number, address. However, name can be the same. We don't know which one is which. And the home phone number, maybe somebody do not have a home phone number. And the address, one address, many people. So for the social security number is unique. So we can use such a attribute to search data because it's a unique, only one, identify. So at that time, this is called key attribute. It's the same concept as a key in entity relationship, the ER model. However, intuitive social security number unique. We know what is a unique or not. But when you see the real database model, sometimes it's not clear to find the key attribute directly. So when we define a key, let's see later I will show you. So I think that we need to go through this one. That's the key, okay? Sometimes such a key is not given. Sometimes the key can be composite, like the attribute A plus B. First name and last name can be the key, something like that. So that is, at that time, we call if you create a new key to identify, it's called the artificial key or surrogate key. So relation has a key. This is really important. That is one of the different things from the ER model. We will see later. Okay, so when we design the database, our goal is to design the schema. Schema is, as we have seen before, schema means it's a description. We try to find the description of a database. In other words, we try to create the schema of the database. The schema has a number of relation, number of table, and each relation has a, from now on, we are going to use so relation name. Usually it's not strict rule. Usually we use capital letter. Then attribute 1, attribute 2, and so on. So this is the naming notation. So for example, the customer relation. Relation has a number of a set of attributes. Customer ID, customer name, address, and phone number. They can be either the lower letter or capital letter. There's no strict rule, but usually the name of a table, name of a relation is capital, uppercase. And attribute name sometimes uppercase, sometimes the lowercase. It doesn't really matter. But we do not use common style, the naming, like the customer, like that. We do not use such a thing. But sometimes ID, number, like that. But instead, we like the underscore, the naming rule, like the customer name, underscore name. Instead of a hyphen, the underscore is more popular. Close to Python naming. Python you use a lot of such a thing, but it's not strict. The most important part is if you join any project, your project manager will let you know what kind of naming rule they are using. So it's not very strict. So I'm not going to explain detail. But we have the relation name and their attribute, like the customer and the so on. This is the schema. If you have the number of at the relation, that will be the schema. Then, when we find, for example, we have the customer, the student, the name, ID, and the major. So this is our schema of the student relation. Then, if we build a real database, real relation, for example, Lee, ID1, CS. How can we get such a data relation? Tuple. When Dr. Yev proposed, he used concept of, this is called a domain. Domain is kind of big jar. Okay? This is a really big jar for the name. This name domain has Lee, Carter, James, and Smith, and John, Nee, and such all possible name is inside. But it doesn't include name of cat, name of dog, name of major. We do not keep only name of a student is in this. And then ID. There might be possible 1, 2, 3, 4, such all possible ID. It's an infinite set. It's a finite set. This is a major. CS, CE, EE, ME, psychology. All possible. Okay? Then, when you build a relation, let's pick V1 CS, V1 CS, and the pattern, and the number 2, and the E. Like this. You can pick such a value. This is value. So domain value is used to create the relation. Okay. In mathematically, this one will be defined as like this. So when you create the relation, okay, R is the tuple, small r. So tuple of a student, domain, from one domain, A1, name, and another domain, the A2, and then so on. Then X means Cartesian product. So what is a Cartesian product in set theory? Cartesian product. What is an intersection? Same. And what is a union? Either of them. What is a minus? A minus B in set. A not B. Then what is a Cartesian product?
Other than
So for example, A is 1, 2. B is A, B, C. What is a Cartesian product A and B? I think you learn 1A, 1B, 1C, 2A, and 2C. What is it? All combination of each element. So this is called the Cartesian product. We can apply Cartesian product to create the tuple. Okay, which means one for each domain, then Cartesian product. We can have such a set group of element value, group of value for each element. Then eventually this will be group of tuple. This is the relation. So Dr. E. F. Cole, first time when he proposed his idea of the relation, there is no concept of string, no concept of integer, no concept of the data type. Instead, he used the domain. Okay? From each domain, we can pick one value, one value, one value, Cartesian product, combine. Then we have set of value that is the tuple. Then one tuple, second, third, a group of tuple form a what? Relation. So this is the definition of the relation in relational database model. At the time, this is called the name of relation, student. And this is the name of attribute. And then eventually we can create the name of the student domain. And from the domain, we can create the student relation. Like, okay, next class we are going to continue the relational model. Next class, please bring your laptop. Okay, at least should connect the internet. Okay, so browser, read the browser. We don't need any other installation, only the browser. And I think the Chrome is better because we are going to use a GCP. So if you are not sure, please do not activate your coupon. Keep the, I send the all message to all students. But the key part, if you want to activate by yourself, please use incognito browser because GCP does not allow UB account to use the GCP because it's the UB policy. So UB blocked to use the GCP. So instead, you need to use Gmail account. Anyone who do not have the Gmail account? Everybody has. If you do not, please create one. It's free. So we are going to use the individual Gmail account. Then we will activate and start to use the GCP. Eventually, I think the next time we can, the Thursday, we can create the MySQL database. So you don't have to download the MySQL or whatever, just create the GCP account. Then please keep doing your homework and the hand assignment and so on. Today you need to submit the two things. One is if you miss the EI diagram, hand-drawn EI diagram, you need to submit. Second, the revise, the pop quiz. Okay, two things. Revise the pop quiz. Then this is another hospital management. You will see. This is for your